All right, this is a video from a long time ago, but today's date is August 30th, 2022. And I want to talk about the penguin problem that we did a while back because I've never done an answer key for it. So if you remember from the book that we read in class, 365 Penguins, on one of the pages, they talk about how much it costs to feed them on day number 100. So on day 100, this is what they say. They say that a penguin eats, one penguin eats 2.5 pounds, so that's LBS, pounds of fish in one day. They also say I should maybe do a cursive L, 1 pound of fish costs $3. And they do the math on that page to figure out how much it costs just on that day 100. And I can run through the math really quickly right now too, and say that if you have 100 penguins, and we know that I'm going to do this multiplication out. So I'm going to do one penguin eats not 1 pound of fish, but 2.5 pounds of fish. I'm going to put a little fraction here. And notice my units canceling out as I'm doing this. Penguin and penguin are now gone. I'm left with pounds of fish. How do we get rid of pounds of fish? Well, we have pounds of fish here. So that pounds of fish has to go down so that I can cross off with pounds of fish and pounds of fish. I can say 1 pound of fish is $3. And yet again, units, pound of fish crosses off. And you just have to kind of multiply all these numbers together. So you are left with a unit of money, which is what they're looking for, which is really, I'm going to do these two first. 3 times 2.5, I think, is what I think they do 2.5 times 100 in the book. Maybe I'll do it that way. So that's 250 pounds. Well, I already got rid of the units for pounds, so maybe I can undo pounds. 250, and then eventually they multiply by 3, and then that is the amount of money. So that's going to be $750 just on day 100. And the question that I posed in class was, what happens for the entire year? How much money do they spend on the entire year? Because essentially you have day 1, and then you have to add the price for day 2 plus the price of day 3 plus ... plus day 100, which we just found, plus ... plus day 364, and then finally plus day 365. And we know on day 100, I can put the price maybe in red, on day 100 the price for just that one day was $750. But that's not very easy of a problem to do. So the way that we learned how to do this problem was we talked about the story of Carl Friedrich Gauss when he was in elementary school, where his teacher gave him the problem, what is 1 plus 2 plus 3 plus ... plus 97 plus 98 plus 99 plus 100, and then under a minute little Carl comes back and shows the answer. And the general method that he used was noticing that if you pair up the first and the last number, these add up to 101. Same thing with the second number and the second to last number. This also adds up to 101. Same thing with the third number and the third to last number. I can draw the arc maybe a little bit better. Should go to 99. Those add up to 101. And all those sums add up to 101. So I have 101 times the number of rainbows, and because I'm making pairs of rainbows, I'm using up 2 numbers to make this one rainbow. I'm dividing the total number of numbers. There's 1 number, 2 numbers, 3 numbers, 98, 99 numbers, and 100 numbers. There's 100 numbers in this list. So if I'm using every 2 to make a rainbow, then 100 divided by 2 gives you the number of rainbows. And then we generated a formula. We basically said this. We said that for the for this first number, that's just going to be first plus last. That's how you get the 101. And then we're going to multiply this with the number of rainbows, which is the quantity of numbers that you have, and then you just divide that by 2, because every 2 makes a rainbow. So the number of rainbows for that problem that Carl Friedrich Gauss did was 50, and then this eventually turns into 101 times 50, which is equal to 5,050. And that's the cool little answer they got for his teacher. This formula that I've just written down, though, is very helpful for solving what we have up here, right? Because we have, if we can figure out what the first price is, the last price is, then we can get first and last price. We know the total number of quantity. The total number of quantity is 365. In class, I talked about what happens if this is odd, but the takeaway was it doesn't really matter. You can still use this formula. So what we're after now is, what is the first day, what is the last day, what is this price, what is this price, because that's how we're going to make our first rainbow, and then we're going to multiply it by 365 divided by 2, and that should give us our answer. So coming back here to day number 1, we found that it's essentially doing this same step right here, but instead of 100 penguins, we're changing that to just 1 penguin. So another way of thinking about it is it's the answer, but I can divide by 100. I can move the decimal place. Every 0 that you see is 1 time that you move the decimal place. You move it 1, 2, and the decimal place ends up right there at $7.50. So on day 1, it costs $7.50 for the first penguin, and you don't even need the second penguin because it's not needed for the formula that we discovered. We do, however, need the 365th penguin, and this is where it's nice to rehash all of this math one more time. Again, essentially all I'm doing is I'm taking 100, I'm swapping it out for 365. So labeling my work so it's easy to see what's going on, let me make a little squiggly area and say this is how much for 365 days. You're going to do, I'm essentially taking this shortcut of ignoring the 1, ignoring the 1. I'm just going to do this number times this number times this number and get the answer. It's going to be 365 times 2.5 times 3. I am dyslexic and I apologize. That's not 365, that's 356. There's 365 like this. And multiplying these together, what are we going to get? Well, I'm going to do the 2 easier numbers first. 2.5 times 3, I already know that's 7.5. And now I need to do 7.5 times this 365. So here we go. I have not very much room. I'll try to fit this in here. Maybe if I zoom in, I can do it better, huh? 365 times 7.5. I'm probably going to have to move that out of the way. Here we go. So I'm multiplying these together. 5 times 5 is 25, carry the 2, 5 times 6 is 30, carry the 3, 5 times 3 is 15. Oh my goodness, it's been a long time since I've done multiplication. I apologize. I messed up in the last step, didn't I? 6 times 5 is 30, but I forgot to add the 2, so it's 32, and then I carry the 3. There we go. I'll make a mistake. 5 times 3 is 15, 16, 17, 18, so 18 goes there, and now I'm going to be multiplying 7d, and I'll move the decimal at the very end. So I'll put the 0 there for now as a placeholder, and now I'm going to do 7 times 5 this direction. 7 times 5 is 35. Carry the 3, so I'm going to put 3 right there. 7 times 6 is 42, and then add the 3 is 45. Carry the 4. 7 times 3 is 21, plus the 4 is 25. And I need to add those straight down, which I can do up over here. I know my work isn't the neatest right now. The last digit is going to be a 5, and then I'm seeing the 2 plus the 5 is a 7. And then I'm seeing 8 plus 5 is 13, so I'll just do a 3, and I'll carry the 1 up here. And then that's going to be 7 and then 2. And then don't forget at the very end that you count the number of decimals. So there are 0 decimals that we have to move right there, so 0 places that we need to move to the left, and 1 to the left, so I'm going to move this 1 to the left. And we get our final answer of $2,737.50 on the last day. That is a unit of money. So I can come back up here. Maybe I'll do an arrow to remind people that this was the unit of money that we found up here. Too long of an arrow. I'll come like that. So $2,737.50 on the last day. And now we can use that formula. We can come down here and say, okay, the first day, as we said up above, I'll maybe draw an arrow to come back down here. The first day was $7.50 plus the last day, which is now another arrow going to come down here. Yeah, I'm realizing that I don't want to run into my formula, so let me move this down a little bit. And maybe I can make this arrow a little bit longer. Sure, let's say that can come down here. And now I have plus the $2,737.50. So there's my arrow right there. Just following the formula, I just did that here, and now I need to multiply by the quantity over 2. So now I need to multiply by the quantity. There's 365 days divided by 2. If we do this correctly, I appreciate not using a calculator. Strengthen the mind here. I'm going to have, I can see that the 50 cents and 50 cents will add to a whole dollar, so I'll keep that in mind. It will be a whole number. I'm going to have, I'll just write out so I don't make a mistake, 2,737.5, don't need the 0, and then 7.5. So adding these together, 5 and 5 is a 0, carry the 1, 7 and 7 is 14, now it's 15, carry the 1, and all of those are 0, so it's 274. And then the decimal comes right there. So each rainbow would add up to 2,745, and now we're going to multiply this number, and I'll bring this down here. I'm going to multiply that number by that thing divided by 2, and I might as well divide that down by 2 now. So what is 365 divided by 2? Well, they actually tell you this in the book. They say half of the penguins, 182 of them are female and 182 of them are male. So I know that this number here is going to be, maybe I'll do a little arrow. This thing is supposed to be 182.5. And you might be thinking, you can't have half of a penguin, and you can kind of, because there's that middle number. That's where that half comes from, the half of a rainbow. All right, and then finally, this number is going to come down here, and we're going to multiply. So I have a giant multiplication problem, 182.5. The decimals aren't lined up, but that's okay. I'll just remember to count one decimal to the left at the very end. Multiplication time, guys. Let's see how good we are. So 5 times 5 is 25, carry the 2. 5 times 4 is 20, carry the 2. I added the 2 as well, so I got 22. And then 5 times 7 is 35, 3, 6, 37, carry the 3. 5 times 2 is 10, I get 13. All right, I've used up the 5. Here we go. 2 times 5 is 10, carry the 1. I should do a different color here, huh? So 0, carry the 1, so there's now a 1 up above the 4. 2 times 4 is 8, now it's 9. 2 times 7 is 14, carry the 1. 2 times 2 is 4, but I got the 1 as well, so I get a 5. On to my next color, 0, 0. I start with 2 zeros. Remember, this placeholder, this was the placeholder, and this 0 actually came from a 10 from the multiplication. All right, I've used up that 2. Now I'm on to the 8. 8 times 5 is 40, so carry the 4. 8 times 4 is 32, and that turns into 36. So I'm going to carry the 3 right here. 8 times 7 is 56, 57, 58, 59, carry the 5. And 8 times 2 is 16, so that turns into a 21. Excellent. And now, finally, I've used up the 8. I'm going to go back to blue, I guess. I'm going to multiply the 1, and the 1 is really easy because you just kind of copy down all of these numbers yet again down here with the correct placeholders. So with the placeholders, I had one placeholder, then I had two placeholders, so now I'm going to have 1, 2, 3 placeholders, and I'm again going to just copy down those numbers. 5, 4, 7, 2. And now I just need to add those all up. All right, I have 5, a 2, 7 plus 9 is 16, carry the 1, 3 plus 1 is 4, 8, 8 plus 11 is 19, so I'm going to put a 9, carry the 1, so I have a 2, plus 5 is 7, plus the 9 is 16, plus the 4 is 20, so end with the 0, carry the 2, 2 plus 1 is 3, plus 7 is 10, so it's a 0, carry the 1, and I get to 5. And don't forget, at the very end, we do need to move our decimal place. Okay, there's no decimal places I need to move back here, but there's this one decimal place. I need to move 1 to the left, which means I'm going to move the decimal place 1 to the left. There is our new decimal. And unless I've done, I mean, there's a lot of mistakes that I could have made because I did everything by hand. But theoretically, this should be the amount of money that the Penguins cost for the entire year, summing up the day 1 plus a day 2 plus a day 3, etc. So my final answer, I'm going to write it out in words. For 360, that's a terrible 6, 365 penguins, it cost, it maybe past tense, it costed, it feels weird, it cost, I think it's past tense, there you go, it cost, here's your big number, $500,962.50. Wow, that is a lot of money. And then I told everyone, hey, that was a long process. We did this all in just one day. I told everyone, well, if you really want to check your understanding, you do this whole process again, but instead of doing penguins, you do polar bears. Because if you remember at the end of our book, 365 Penguins, that at the very end, they start doing it with polar bears. And I did a quick Google of how much a polar bear eats, and instead of eating, I don't know what they eat, but Google told me instead of eating $7.50 per day, they eat $35 of food a day. And I don't know if that is right, but we're going to go with that number and see what sort of math problem we get from that. And it's going to be very, very similar, because essentially we're going to have, I'm going to draw out the days again. We need day 1 and we need day 365, and then we need to add up all of those days together. So on day 1, I already told you it costs $35. And on day 365, well, there's 365 times $35 per bear. So let's do that off to the side. We have 365 times 35. 5 times 5 is 25, carry the 2. 5 times 6 is 32, carry the 3. 5 times 3 is 15, 16, 17, 18. And now we go to the next line. 0, use up the 5. 3 times 5 is 15, carry the 1. 3 times 6 is 18, add the 1 to get 19, carry the 1. 3 times 3 is 9, but plus the 1 is 10, and then I need to add these down. No decimals to worry about, which is nice. I get a 5, then a 7, then a 7, carry the 1, a 2, and a 1. All right, so that means just on day 365, it cost $12,000. And let's transfer this up here. That's $12,775. And if we got a decimal, that would be weird because we've never had decimals. In the previous problem, we had decimals right off the get-go, 50 cents. So it would make sense if our answer had a decimal, not of 75 cents, but like of 50 cents. That would make sense. This one, we should have no decimals. It should always be a nice integer. So again, I'm going to be using that formula that we discovered in class. The general formula for that sum is going to be, maybe I can do an equal to sign. The sum is equal to the first plus the last, and then you're going to multiply by quantity quantity divided by 2. And quantity divided by 2 is still 365 divided by 2. That hasn't changed. So if you remember 365 divided by 2, we did that right over here somewhere. Quantity divided by 2 went to here, went to here. So I'm just going to borrow 182.5 again. So 182.5. And you might be thinking, uh-oh, Mr. Sindel, you said no decimals. Don't worry, this will be an even number. It has to be, otherwise we got a decimal and we've definitely made a mistake. So let's go ahead and add our first number and our last number, our first number and our last number for this inside, right? And I'll be careful with this. So this is going to be, I'll do it in red, it's going to be 12,775 plus 35. Adding these together gives us 0, carry the 1, 3 plus 7 is 10, but now it's 11, carry the 1, that's going to be an 8, 2, and 1, $12,810. And now, the penultimate step, we now need to multiply, and I'm going to do this off to the side, that's the end of school. I now need to multiply 12,810 times this down here. 182.5. Here we go. 5 times 0 is 0. That's not a placeholder. I literally just did this 5 times 0, and then I'm going to do 5 times 1. 5 times 1 is 5. 5 times 8 is 40. Carry the 4. 5 times 2 is 10. Plus 4 is 14. Carrying the 1. 5 times 1 is 5. Plus 1 is 6. First one done. Next. 2 times, oh, we need a placeholder. I'm going to do an underline if it's a placeholder. And then I'm going to do 2 times 0, which is another 0. 2 times 1 is 2. 2 times 8 is 16. So I carry the 1. 2 times 2 is 4, but plus the 1 is the 5. 2 times 1 is 2 with no extra to add. And I'm done with the 2. Moving on to the 8. I need 2 placeholders, and then I'm going to do 8 times 0, which is 0. 8 times 1 is 8. 8 times 8 is 64. I'm going to carry the 6. 8 times 2 is 16. Add the 6 to get 22. 8 times 1 is 8. Plus the 2 is going to make 10. All right, and I'm almost there. Finally, I'm going to multiply everything by 1, and that's really nice again, because as long as we have the correct placeholders, we're going to have 1, 2, 3 placeholder values this time. All I have to do is copy down these numbers again, including that 0. I am going to be copying that one down as well. So I'm going to do 0, 1, 8, 2, 1. And now I simply need to add, and I should get my final answer. Here we go. 0. Thank God, because I know that I'm going to be moving that decimal 1 to the left. Nothing from up there, but 1 to the left from right there. So I'm going to be moving it 1 to the left. And that, if that was not a 0, I know I made a mistake. So there's our decimal place. I moved it preemptively. Last number is going to add up to 5, then 2. Okay, I have a bunch of numbers happening here. The 4 and the 6 add up to a 10, plus the 8 is the 18. I'm going to carry the 1. And adding all of these up, so I have 1 plus 6 is 7, plus 5 is 12, plus the 4 is 16, plus the 1 is 17. Carrying the 1. That might make people weird. I'll put the 1 smaller. Adding these up, 1 plus 2 is 3, plus 2 is 5, plus 8 is 13. Carry the 1, that's a 3, that's a 2, and where the commas go? Comma, comma, wow! That is a lot of money. So for 365 days of polar bears, and we had an assumption here, so I'm going to assume $35 per bear. Then that would cost over 365 days $2,337,825 dollaroos. And I am curious. I'm pretty sure we could have used a shortcut. Let's see what happens if I were to just do this. Take our last answer. I think the shortcut is this. Let's test the shortcut. The shortcut that we could have used for the penguins and for this one is to simply do easier numbers and then multiply by 35 at the very end. So the shortcut is to do 7.5 and factor that out, and then do 1 plus 2 plus 3 plus dot 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 plus 364 plus 365. And that would be for penguins. So I'll write penguins. And similarly, the shortcut here should have been do $35 times 1 plus 2 plus 3 plus dot 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 plus 364 plus 365. Let's see if that actually works. And that was for the polar bears. Polar bears. No one discovered the shortcut, which is why I went through the long and tedious way of doing it. But I do want to show you the shortcut. For those of you that are sticking around, thank you. So for sigma notation, for summation notation, there is a shortcut for this as well. But I'm just going to use that old-fashioned formula because I think it still works. It's going to be first plus last. So it's going to be 365 is last plus first. First plus last times the quantity, so times 365 divided by 2, which is still a bit of a problem. But I'm going to be using the same calculation here, and I'm going to be using the same calculation there. And then at the very end, I can just multiply by 7.5, which might be hard. I don't know. I'm going to still do it by hand because I want to see if I can get the same answer twice by hand like the ancient mathematicians. So I'm going to get 366 times 365 divided by 2, and you can kind of see the pattern now. You're like, oh, that looks oddly familiar. This kind of looks like n times n plus 1 over 2, and if you're like in math club or in mathletes, whatever we're calling it, that is the general pattern for sum of a series. I'll just say series. Arithmetic series? Arithmetic? Something you can put in your tool belt for later. Anyway, I can do the 366 divided by 2 right now to make this a little bit easier on my life. That's going to be 100, well, 18 gives you 36, right? I think so. 18 gives you 36, and then I need a 3 as well. So 183 times 365. Let's see what that is real quick. It's really tempting to use a calculator right now. I'm pretty tired. 365. Endure, Mr. Sindel. 183. Multiplication. Go, go, go. 3 times 5, 15. Carry the 1. 3 times 6, 18. But you have to add the 1, Mr. Sindel. So 19. Carry the 1. 3 times 3 is 9. But plus the 1 is 10. Placeholder value 0. 8 times 5 is 4D. Carry the 4. 6 times 8 is 48. But now it's 52. Carry the 5. 8 times 3 is 24, so it turns into 29. I need now 2 placeholder values. 1 times 5 is 5, 1 times 6 is 6, 1 times 3 is 3. Add these all together. 5, 9, 7, 6, 6. All right, I'm pretty sure that is correct, but I'm not 100%. So this is equal to 1 plus 2 plus 3 plus dot 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 plus 364 plus 365. That is what we just found. Now what I'm going to do is I'm going to multiply that whole quantity by 7.5 and see if we can get to the penguin answer back over here, see if we can get that number, and then I'm going to multiply that same number right here by 35 and see if we can get to our polar bear answer of a little over 2 million. All right, this is the fun part. I'm hoping that these two ends of mathematics connect up, because if not, we have made a mistake. So here we go. I'm doing the check penguins. We check our penguins. We should have 66,795, and we're going to multiply that by $7.50. So 7.5. 7.5. Let's see what we get. 5 times 5 is 25. 5 times 9 is 45. Add the 2. 5 times 7 is 35. It's going to turn into 39, carry the 3. 5 times 6 is 30, 33, carry the 3. 5 times 6 is 38 again, so I get a bunch of 3s there, which is kind of satisfying. And next row, placeholder value is 0. 7 times 5 is 35. Carry the 3. 7 times 9 is 63, turning into 66. Carry the 6. 7 times 7 is 49, turn that into 55. Carry the 5. 7 times 6 is 42. That's turned into 47. Carry the 4. 7 times 6 is 42 again. Now turn into 48. And add our values straight down. We have a 5, a 2, carry the 1, 6, carry the 1, 9, 0, carry the 1, 2, carry the 1, 5, and that's not what we got. Oh no, it's 520,000. We got 500,000 over there. Yeah, and it happens. I was really hoping to get the exact right answer, and I'm curious on what the mistake was. This is where we are now able to unlock the calculator to see what the mistake was, because otherwise I'm going to go insane searching for this error. Hey.
I need help downloading this and turning it in because I'm done.
It looks really good.
Thank you.
Alright, so if you just right click, save image as...
Oh yeah, you told me that.
It's okay. Let's call it Emma. Save to your desktop, and here you have this open. Lovely. Add or create file. Throw that in there. Oops, a little bit too fast. My computer's not keeping up with me. And in theory, let me check if this picture actually looks good. Yeah, there it is. And it's there. Thank you.
Thank you.
All right, let's use a calculator. So I'm going to use a scientific calculator to figure out where we went wrong. So calculations that we need to check. Ooh, okay, I'm going to try the split screen here. So if I go like this, I can say you move to the left, and let's move wherever my good notes are. Where am I? There. Good notes on the left hand side. Oh, they can view floating windows. That's kind of nice. All right, so the first thing that I would like to check, can we have this? There we go. That is a little bit better. I want to check this calculation right here. So I'm going to do 365 times 183, 66795. Okay, that one worked. Maybe I made a mistake in the multiplication right here. Let's check that one. So I'm going to say multiply that again by 7.5. I did make a mistake. Okay, so the mistake happened somewhere in here, and I didn't show my work. What a terrible teacher. All right, well, let's go ahead and see where the mistake was. I'm going to show my work this time. So adding, I'm going to keep multiplying again straight through. So let's check. 5 times 5 is 25. There's the 2. 5 times 9 is 45. 4, 6, 47. So there's a 7. Carry the 4. 5 times 7 is 35. 36, 37, 38, 39. There's the 9, and carrying the 3. Now I'm going to do 5 times 6 is 30. 31, 32, 33. There's the 3. Carry the 3. 5 times 6 is 30. Plus 3 is 33, and I do get 33. Okay, so everything in that line is double checked. That one's good. I must have made a mistake here or there, right? So I do have a placeholder value, didn't make a mistake there. I do have a decimal place that I eventually need that I didn't do because I was so dismayed at that 2. But let's see where the answer should be. Okay, so 7 times 5 is 35. There's a 5. We carry the 3. 7 times 9 is 63, 64, 65, 66. There's the 6, and I carry the 6. 7 times 7 is 49, and that should turn into 55. So there's the 5, carry the 5. So far, so good. Now I'm going to do 7 times 6 is 42. That's going to turn into 47. There's a 7, carry the 4. 7 times 6 is 42, 43, 44, 45, 46. Oh, why did I do 46? I did 48. Why? Okay, there's a mistake. Silly me. It happens. 40. I'll make it red. That was the mistake right there. And now if I add straight through, that's a 5, that's a 2, carry the 1, that's a 6, carry the 1. That turns into 4 plus 5 is 9, no carry. 3 plus 5 is 9, no carry. This is looking pretty good so far. 3 plus 7 is 10, carry the 1 right here. 1 plus 3 plus 6 is 10, which we already carried. That's why that turned into a 5. But we can now correct this into the 0. Is that what we got? 9, 6, 2, 5 at the very end. 9, 6, 2, 5, and then we have to move the decimal place. Yes, we got it. So I'll move the decimal place, and we check the answer 2 different ways. That does work. So the main thing that you should take away from all of that work is it's okay to make mistakes. We all make mistakes. We're all human. But here's a cooler way of doing this. Do this first, which is easy to find with this formula, and then just multiply by 7.5 at the very end. So theoretically now, and I want to redeem myself and do this by hand, I'm going to multiply that number by that number, and I'm going to get, and there is some drum roll somewhere, that number right there. All right, here we go. It's about the same amount of work as the last problem because it's just the same 5-digit number times a 2-digit number. Here we go. So I'm gonna say down here I'm going to check polar bears. All right, and I need as much room as possible. You're gonna move right there. So checking the polar bears, I have 66,795. That is from our sum, if you'll remember. So that comes down here, and I'm gonna multiply that just by 35 times 35. Here we go. 5 times 5 is 25. Carry the 2. 5 times 9 is 45, 46, 47, carry the 4. 5 times 7 is 35, turns into 39, carry the 3. 5 times 6 is 30, 33, carry the 3. 5 times 6 is 30, 33 again. Lots of 3s again. All right, so, and that's nice because we already did a 5 and a 5, and we got this exact line and got that exact line, and they're the exact same. So I know I haven't made a mistake yet. Now is when I can make a mistake. Now I'm multiplying by a 3, which is a little bit easier than a 7. So placeholder value, don't forget that. 3 times 5 is 15. Then I have a 1. 3 times 9 is a 27. Carry the 2. 3 times 7 is 21. 22, 23. Carry the 2. 3 times 6 is 18, 19, 20, carry the 2. 3 times 6 is 18, 19, 20. Again, please add up to the correct value. There is no decimal to move at the very end, so this is the final answer after I get all of this. I have a 5, a 2, carry the 1, 7, carry the 1, 7, 3, 3, 2. I don't even remember what our answer was, but I know it was a little over 2 million. So 2337, 2337, 825. 825. Uh-oh. I got an 825. And down here I got a 725. Do you guys see that mistake? I have an 8 there and a 7 there. That's the only mistake. Well, which one is wrong? And this is where I don't have the time or the patience. So we are going to, oh, I should just do this, huh? Split screen. Can this just slide over to the left? There we go. All right, so let's do 66795 times 35, 825. I did make it. So what's really cool with that is I did all of that work correct, and yet again I couldn't redeem myself. No, it's okay. It happens, guys. Okay, so that does mean I did make a mistake. Let's go ahead and find it. And it's one of those things where recording this video, I'm wondering if someone already caught it. I did go kind of fast, so maybe you didn't catch it. It happened somewhere around there. So 5 plus 0 is 5. 5 plus 2 is 12. So I carried, I'll show my carrying work. I carried the 1. 1 plus 9 is 10, plus 7 is 17, not 18. So I must have made the mistake earlier. So the mistake has to be right there by process of elimination, right? So where did that 7 come from? Well, that 7 came from doing 3 times 9 is 28. I forgot to add that 1 right there. Dang it. Well, okay, 3 times 9 is 27, 28, which means this number right here is an 8. Make it red. That was my mistake. 8, which means this number down here is an 8. And yet again, I'm showing you that the shortcut does indeed work. I'm not going to apologize for making mistakes. I like showing you that I'm human too. I make mistakes all the time. I just try to edit those out, and I don't really care now about editing them out. So sorry that you had a longer than normal video, but that is the complete solution to the polar bear problem that I asked for a checking your understanding extension to our penguin problem. And I should have a money symbol here. It's a little bit annoying that I don't have that. And the money symbol there. Thanks for watching, guys. I'll catch you later.